have to know your fractions when we get to the synthetic division. Let's go ahead and test either positive or minus 1/2. Who has a preference?
Positive.
Positive 1/2. Okay, I'm going to do fractions instead of decimals, because that's my preference. But you may use decimals if you want to, but on things like 2/3, that would get ugly. So we'll try positive 1/2, and my coefficients are 2, 4, -2, -4. Now, remember, you guys have probably gotten in the habit of just writing a 1 down here no matter what, okay? The rule is actually you bring down the first coefficient. So now that's a 2. In this case, that'll work out pretty well, because what's half of 2? 1. So 1/2 times 2 is 1, and boom, we're done with fractions. It won't always work out that nice. It won't always, but it often will, because...
No,
We're not done with fractions. Keep going.
Oh, no, we're not done with fractions. Ha ha ha. Never mind, it won't work out that nice at all. 5, right? 5/2. What's 5/2 minus 2?
0.5.
Yeah, it's going to be positive or negative 1/2? Positive 1/2. What's 1/2 times 1/2? 1/4.
Why?
Is the remainder 0?
No.
No. Okay, so doesn't matter what it is. If you're wondering what we did here to get this, I can rewrite -2 as -4/2, right? And now they have a common denominator, and -4 plus 5 is 1. Okay, so that's how I think of it. You can change these to fractions if you want to, as long as you're careful. All right, you want to try -1/2 now?
Sure.
And by want to, I mean we're going to. 2, 4, -2, -4. Bring down the 2.
4.
This gets me a -1, right? Which makes this 3. 3 times -1/2 is -3/2. Bless you.
Hold on.
Questions at this point?
How?
How?
Just kidding. I'm just kidding.
All right.
Wait, you 2 times.
Okay. Just like up here, I can change the -2 to -4/2, and this becomes -7/2. -1.
And it doesn't.
Yeah, this becomes positive 7/4, which is not the same as positive 4. So neither fraction works. So all the zeros will be whole numbers.
Why did you change to -4/2?
Just to make it easier to add to the -3/2.
Oh, okay.
Because now they have a common denominator, and I just add the numerators.
Were you gonna have a calculator for this test?
Yeah. Yeah, definitely 4. Yeah. You know, I'm going to go to the book and pick one that I know works next. I'm going to try -2.
Gee, I wonder if it will work.
I cannot imagine. 2, 4, -2, -4. Bring down the 2. -2 times that is -4, gets me a 0. Times 0 gets me a 0. -2 times -2 gets me a positive 4. Boom! So please double check me. I mean, it did come out to 0, and I did get it from the book, so I was pretty sure it would work. That doesn't mean I didn't make a mistake on the way. So then this factor, this -2 means that one of the factors is x plus 2, and what's left is 2x squared.
Wait, is it x plus 2 because you changed the sign?
Yes,
Right.
like the first day in synthetic division, remember I said that when you're dividing by x plus 2, you use the -2 here.
Alright.
What's left is 2x squared plus no x's minus 2. And here I'm going to choose to use some factoring tricks rather than go on with the guesses. I'm going to make this, I'm going to take a 2 out of each of these. And that leaves me with x squared minus 1. A 2 out of the 2x
The
squared.
difference of square.
Pardon? What is it, Amanda? Your favorite factoring pattern that you
Square.
weirdly always recognize? Difference of squares, and what does this break down to?
It's x plus 1, x minus 1.
Excellent.
Wait, why did you reduce it to that though? I'm just curious.
Because I didn't think
Oh no, I'm talking the 2 times x squared minus 1.
this one?
No, the one below it.
Okay, I looked at this here, the one above, and I said, all right, this is a quadratic. I know quadratics pretty well. I'm going to use different tricks. I'm going to start with looking for the greatest common factor.
Alright.
Pull that out, get the 2. Left with x squared minus 1. Amanda recognized that's difference of squares. Move the 2 out to here, because we like it that way in math, and change this to x plus 1, x minus 1. And this tells me that my zeros, my solutions, my x-intercepts, are x equals negative 2, x equals negative 1, and x equals positive 1. Okay, so we had to try the 1/2 and the negative 1/2 this time. Please double check me. But none of it, luckily the fractions weren't solutions. If x plus 2 is a factor, then x equals negative 2 will be a solution.
I'm confused though why you use x plus 1 and x minus 1.
Difference of squares.
Oh.
That whole
Never mind.
a squared minus b squared equals
C squared.
a plus b. That's geometry. A minus b.
Yeah. Oh, no, I see.
We use a and b interchangeably, and in pre-calculus we use I for like 3 different things. Yeah, if I were starting over again in 1600, I would change a few things about math notation.
Really?
You should do it now.
I'll start working on that textbook.
Yeah.
Try and get everyone on the planet to agree with me. Questions on this?
Yeah. So. Oh my god. Okay. So you take the factors of the last number.
Yep.
And you put
And
them on top.
Put them on top. And the factors of the first coefficient, make sure you write them in order first. Okay? That would be important. And put those on the bottom, and you've got to test every possible combination. But a lot of the combinations will repeat themselves. All the even numbers in here, when we divided them by 2, we just got 1 and 2 again. And all for tonight's homework, all of the leading coefficients in your book are 2. So you'll only be putting plus or minus 1 and 2 on the bottom. Okay?
What's the homework?
In stereo, we're available.
Okay, so I think I'm good to read
Okay.
this to someone.
Page 363, 48 to 58 even. So that's 6 of these. Oh, I'm sorry, there are some that have 3s on them.
No, there are
Oh,
not.
okay.
Yeah, 52, 54, 56, 58. It was all the odd ones that just had 2s.
That's all.
Yeah, so you just have to do plus or minus 1 and plus or minus 3 on the bottom.
Why can't we just
Oh,
do the
or
odd
you
problems?
could do 40 to 58 odd.
Nah,
Yeah.
we'll do that if you need more review.
Oh, that's
Your
okay.
heads know it.
Often.
Wait, do we...
Thank you, Eliza.
Backwards?